So Malcolm has extensive practical expertise in pasture renewal and landscape restoration, and that makes him a key voice in applied invasive species management. Malcolm, thank you so much, and I'm going to stop sharing and give the floor to you.
Thank you. My name is Malcolm Vermeulen. I'm a conservationist. I've had quite an exciting time in the industry, around about 25 years now. But for the last 10 years, I've been involved in the war against alien plants and bush encroachment. I've developed a number of products that are used all over South Africa, Namibia, and Botswana. We pride ourselves on solutions that are compatible with the environment. And our main line of business is to develop and distribute herbicides that are well needed to take on this war. So let's carry on. I'm a conservationist. We love our plants, but we also respect them. And from the beginning of time, they've been a headache. They are well adapted. Some take our grazing potential. Some suck up excessive amounts of water, loss of biodiversity, and the list can go on. We love our plants. We respect them. We know they're well adapted, but sometimes they do cause problem and they need to be managed. So 2025, December, we're sitting here and plant invasions is still one of the biggest problems that I think all of us face on the African continent. If you want to take on alien plants, you need to look at certain ecological principles. I brought this map up. It's quite an interesting publication, and I'll share it with you guys, where we try to predict the change in land cover over the next 20 years. We take a few variables into account, grazing potential, fire, so forth. And we try to predict the change in land cover. And if you see the whole African continent, at least a 25 to 100% change in land cover, where woodies are dominant. And this helps us with our plan. So the point here on this slide is that it's not limited to a certain region of our continent. Everyone can see a change in land cover, and it's based on a certain limit of tolerance. If you establish yourself, conditions are great and you can reproduce and carry on. So this paints a picture going forward. Early, some of our previous speakers mentioned it, early rapid response. We can see a change is coming. I asked AI to give me a toolbox for solutions for bush encroachment in Africa. Clearly, AI has never seen the extent of bush encroachment in South Africa. Luckily, we've got more sophisticated tools than this, but I'm going to call it a toolbox because that's what you need. There's not one specific method, one specific application. It's a number of methods over time, and usually all have their own place. Today, I'm focusing on the chemical application. And we need chemicals. It's been proven. And the term herbicide is used loosely. It's called a poison. It's called a whole bunch of stuff, weed killers. But basically, it's a substance, natural or synthetic, that kill unwanted plants. Now, I want us to stop there a bit. Natural or synthetic. Okay. Our whole line of work, research, R&D, are more on the natural type of herbicides, okay? Molecules that are existent in the environment that are used then to control unwanted plants. For the purpose of this presentation, let's not look into the synthetic herbicides. They're a bit more harder on the land, more industrial type of use, insecticides, that type of stuff, okay? So don't fear a herbicide. They're quite sophisticated. So I just brought this up. In agriculture and crops, the forefront of research and technology is there's changes every single year. We get new actives, new ways of applying it. But in terms of alien plants and bush encroachment, we move very slowly. Look in the early 1950s, after World War, we started experimenting. We had a few herbicides. They were very hard-headed and stubborn, persistent in the environment for long. As we started playing around during the 60s, we got more selective. Where we are today is very exciting in terms of herbicides and what we have in our toolbox. Like anything in life, we move at a fast pace where there's technology, all types of developments. Herbicides have not been stuck in the 1960s, right? So we get a breakthrough every 20, 25 years with new actives coming to the market. Up until now, we've had very blunt tools. We have some great stuff that are coming to the market now. New modes of action, new actives, and so forth. So where are we in modern development? We are pushed as an industry to have improved selectivity. We want to see herbicides that are selective to a certain group or genus of plants. We don't want herbicides to persist in the environment for too long. They must do their job and get out. And animal and human welfare is very much important. So if you can tick all those three boxes, that's what drives modern development. Back in the day, we had a bomb. We dropped a bomb, 150 kilograms per hectare we used to use. Nowadays, I can give you options that can go up to or as little as 150 grams per hectare. So we've come a long way. We had bombs that we used to blow whole areas, but now we've got scalpel approaches where we can physically get in, work on a certain part, and be so selective. So selectivity. I'm not going to go long here. Remember, I said natural. So what we like to use is molecules that are called auxins. They're responsible for the plant growth down to a mitochondria level, cell division, and it affects many different natural processes within a plant. Have a look there, the all metabolism type of processes. So you almost inhibit growth. Okay. So these are the natural plant auxins or the herbicides that I'm talking to. Okay. They either work on one mode of action or they work on a combination thereof. Mostly it's photosynthesis. I'll show you on the next slide how that occurs. We see it once a herbicide is in the plant. It's not persistent in environment like the older technology. It's active up and down within the plant. We see little green flush. Have a look at those leaves. They can't perform the function of a leaf. And so, yeah, big changes. So I heard a couple of speakers saying most herbicides are non-selective. Maybe back in the day, for the purpose of you guys, it needs to be selective. It needs to be almost systemic. The contact herbicides have a danger to man when applied. It needs to suppress a bit of seed if we can, or little to light residual in the soil. So from not even being in Uganda, but seeing photographs, I know exactly we need a selective herbicide that's systemic. It can have pre or post characteristics and very little to none residual in the soil. So those are the characteristics. Immediately we know where to work from. We don't want to non-selective herbicides in natural environments. At the end of the day, we're trying to promote, protect, and maintain biodiversity. So non-selective will kill everything. Selective kill a certain group of plants. And we want to, for instance, kill woodies. So let's have a look at it. We kill the bankrupt bush, which is Ceriphium. Within a couple of weeks, you can already see the grass germinating. To the right is an acacia selective. Yeah, I'll put it in. Have a look what a non-selective herbicide does. We treat Ceriphium with a non-selective herbicide. It's indiscriminate and it kills almost everything. They have their place in the industry, maybe fence lines and fire breaks, that type of stuff, but not used for you guys. Have a look at what a selective herbicide can do. 12 months after application, the problem plant has been suppressed or eradicated, and the grass has recovered. But the secret here is that any herbicide needs to be applied selectively. Once we apply a herbicide non-selectively, then we get unforeseen results. And the list goes on. There's pom-pom within a grassland. There we wanted a little bit of residual to suppress the seed. 3 weeks after application, the target plant is gone, and we're in and out. So if you have a look, it's regulated by Act 36 in South Africa. It governs all the aspects of herbicide, whether we make recommendations, whether we register new products. So this act should be our or your guardian document. Anything we do is according to Act 36. Now, there's a lot of guidelines in terms of Act 36. Training is very important. So you get the herbicide applicators training, you get a pest control officer, numerous training. That's very important. It also stipulates different requirements for labels and so forth. And this is basically the crux of our Working for Water and our land clear projects in South Africa. Within that, herbicides have different temperaments. Most herbicides that one should use should be not more than the yellow band. Any red herbicides are outdated. And one can work out toxicity from this. How much would a human need to consume? And you see, a human needs to consume almost 49 liters of active. So yes, you want to control alien plants, either in the green, blue, or yellow band. Okay. On the label, always read the label. Somebody said it. It's very important. I just brought this in. There's been a lot of talk on, is it toxic to animals? The newer chemistry, the newer molecules, I find this very interesting. There's actually a forage management. So the molecule cannot be synthesized by an animal. It goes literally straight through the digestive system of an animal. There are warnings not to use a manure for composting. The molecule has not been assimilated and still alive. That composting can then kill sensitive crops. So the molecule can travel straight through an animal unharmed. And this is proven in our wildlife ranching industry, where we use a lot of herbicides within high value type of game. And a lot of herbicides are approved on a national level. So quite interesting. The molecule does not get taken up. Also, there was talk about half-life, and this is very interesting. There are 3 main drivers to break down a herbicide in the environment. It's your immediate environment, your soil, and your climatic conditions, and then the physical properties of a herbicide. Most of the studies have been done in North Americas of the world, where if one looks at the same active in Canada with frozen ice caps and a different soil, that active takes about 300 days to break down. If we bring it closer to Africa, that's a lot warmer, probably more ancient, darker type of soils. That can be down to almost 60 days. Some experts also reckon about 30 days. So the rate of breakdown in Africa is a lot faster due to our climatic conditions. So there are a few studies. It's limited. So there's probably a great gap for further research. But herbicides break down much quicker in Africa than the rest of the world. And then on each herbicide, there's something called a STS, where one can physically go and have a look at the characteristics of a herbicide. The most important to me is ground soil and then groundwater contamination. Have a look on the right. That's the older actives. Very stubborn, high leaching potential, persistent in the environment for long. Aminopyrrolid on the left, very limited, low mobility in soil, 0.6 days over water courses. So we've become a lot more compatible. I don't like the word environmentally friendly. It's environmentally compatible. Have a look at some pictures from the field. Once applied herbicides to a stump, a lot of times we see a lot of biological breakdown on the point where we've treated the stump. We see a lot of saprophytes and bryophytes, borer beetles, and a lot of insect activity. So the misconception is a herbicide is sprayed, everything gets away, nothing touches it. No, a herbicide is made out of carbon, nitrogen. So if you could choose the correct herbicide, it's almost an enhancer of biological activity. Some more photos. Treated borer beetles on beetle larvae on a solanum after it's been applied. A big part of it is also what happens to the empties. We have a great waste management program, and I think that's important going forward. All recyclers, so that all gets recycled. How do we apply it? For you guys, there's probably two main methods we can look at. It's a foliar and a cut stump application. Foliar, we've come a long way with innovative solutions. It was usually the go-to method for staff, manual type of labor. You're limited to trees that are 2 meters and shorter for ground application. Anything beyond 2 meters, you would revert to another application. And we've come far over the last type of years. You can hit a leaf of a target tree many different ways these days. You can bring in the manual labor, high pressure sprayers. Drones are become a game changer. And if it's large homogeneous stands, we can also bring in aerial application. So a number of methods that one can use. It's normally area specific, based on resources, that type of stuff. What I want to focus on is also drones. It's given us the opportunity to be a lot more precise and precision application. We can fly over an area and we can immediately identify trees that are above a specific height. Bush encroachment is normally trees that are specific in a normal height. That's normally one species. So from there, we can get a good landscape view of the area and not go close to our non-target trees. Once the drone takes off, it's got a flight path and we can map out our big trees, stay away from the water holes, so forth. That's how the flight pattern looks with all your big trees and non-target trees marked out. And now remember, guys, this is important. You've got new chemistry that are compatible, that are so soft on the environment. And now we've got precision application methods. So it's very exciting. Seeing is believing. So have a look. These are areas about a year. Same area that I showed you. That's all the trees were marked out. This is a year after application. You can see the target species were Dicrostachys and a few acacias in between. They have all been sprayed, and a year later, you can see there's been good uptake with the non-target trees still doing their thing. This gives us the ability to clear certain areas far away from each other, prevent overgrazing. And then the year after, the method afterwards can be discussed. If manual labor to do clearing, brush packing is great. I like leaving it like this for 2 or 3 years. It catches a lot of seed, it creates a microclimate, and then one can go and physically harvest the wood, or we use fire sometimes in our savannas. So this is how it looks, very soft on the environment, a certain genus of plants. So this specifically, the genus is quite a large, it's Fabaceae. So any seeds with a pod bearing, that genus. Another photo from the top where you can see we clear different areas over time. This can be done with a high pressure sprayer, it can be done with knapsacks, but this is your golden opportunity. A tree is actively growing, it's stable. It is the golden opportunity. I'll now explain to you why later. Just to show you in action, we have set it to miss all the non-target trees. So it sprays around your target trees and misses the non-target trees. If we are delayed for time, I'll share this and get it to you guys. Okay, I'll send that to you guys. Anyone can contact me. This is a view from the ground up. You can have a see your combretums, the Dicrostachys has dried out. The immediate release of nutrients, the grass is evident. There'll always be follow-up. You can see that little one there. So that's where the manual labor comes in. A guy that promises follow-up is lying. So we always plan for a follow-up thereafter, and then the trees can be harvested. What we're doing at the moment is almost a coppice application. You've harvest trees, and then you can wait for sufficient regrowth to occur, and then we can spot spray it. That works. It's a lot more tough because you've declared war on the plant. It has gone into a coppice. It's usually multi-stemmed. It grows aggressively. So it's been well documented in science. Treating coppice is a lot more difficult. That's why I say take that golden opportunity. Spray it first and then come back and follow up. And this is why. I mean, we call this the underground forest of Africa. Have a look at that extensive root network of Senegalia mellifera. It's in sandy soils, but it gives you an indication of what we're up against. These trees have survived drought and defoliation with elephants. And I think that's currently what we're doing. We have declared war and we've just made them upset. And there's also an ethical consideration. This is hard labor. It's difficult. So there's also ethical consideration towards the man and the community. It's easier to spray it and then come and clear the dead trees. A cut stump can be applied, yes. It's a lot more selective to the base of the stem. We usually treat each multi-stem. Equipment's very important. It can make or break an application. Have a look at the top is 100 liters per hectare. 400 liters per hectare is 4 times the cost, 4 times the active into the environment. So this is where it goes wrong, is the physical application thereof. And this is where the training is important. We need oils that helps us penetrate the leaf cuticle. Very important. We need a dye so we can monitor. It's an indication tool for management to see where it has been applied, how it's been applied, why are we messing, that kind of thing. One of our other speakers did mention you need to know your land before you start clearing. Where are the big trees? Where are the small trees? The basic principles of alien plant management is to prevent further spread, isolate your infestation, and then manage that. So it'll be good to know where is it, younger trees or older trees and so forth. And this is very important. If you want to have a look at our national park, bush clearing or alien plants, you need to see return on your investment. So along tourism roads, water holes, lodges, prevent any further spread. The road networks are amazing. Your ecotourism value has decreased big time. Start with your road networks. That where it's thick. Bring in a different application method there. Have an integrated approach. It's not just one silver bullet blanket approach that's going to ultimately win it at the end of the day. The drone is great. To know your land, you can just fly over it. We can know where the density are, and this helps us planning. There to the left, you can see it's high density. And there we can adopt a different method or know that might require 1 or 2 follow-ups. So they are a game changer. If you've got the long-term data, that's great, the field work, but that's going to take time. And I don't think we have time at the moment. Another picture of what you see. So what we've picked up in savannas, that grass production actually increases with woodies. You need to maintain it on that balance. Once bush density increases, your grass production decreases. So that's where I see effective management is to maintain on that point where grass production still increases, but you suppress the woodies. Let's check a site in Lephalale, South Africa. It's quite old, but there's great data. In 1995, we cleared every single woody, so total clearing. Come back in 2008, it's just completely overgrown. It's a hardy species. There's been no return on your investment. we call this an unstructured savanna. So we don't want an unstructured savanna. If you look at the plot where we've cleared every second tree, 13 years later, it looks great. The grass production is high. The area is stable and resilient. So that is bush clearing, alien plant management. We create structure. Once we've lost structure, then we're doomed to fail. So here's my optimum structure. You have woodies with shrubs with intercepting grass. That's your typical savanna. Unfortunately, we sit with this, and we have a lot of target trees under big non-target trees. The root systems are 3.5 times the canopy sometimes, and we try to control under canopy, and we lose big trees. Unfortunately, that has been the way because we haven't had the tools up until now. So now we have chemistry where we can physically clear under trees, next to trees, without the risk of losing a big tree. And that's the structure we try to get back, okay, at the end of the day. Somebody mentioned that they've uprooted and derooted. I think it was Philemon. Philemon, you're in a very important state here. You've committed. You've had a dramatic decrease in woodies. The grass will be great for a couple of years. The grass is that green. But soon it's short-lived. There needs to be some sort of follow-up. Otherwise, you're going to be left with an area worse off. And this is where alien plant control is won or lost, on that follow-up right there. So we need to always plan for that follow-up. It's expensive the initial, but it does become cheaper over time. And this is what we strive towards. People come to Africa to experience this. The photo on the right is from the Northern Cape, where they're quite hard on our land, non-target trees. And have a look at that. I mean, structured savanna versus the unstructured savanna, the ecotourism potential. This is why people come to South Africa. So if we're going to do anything on the right, then we shouldn't do anything at all. So yes, we do preach chemical control. It's part of your toolbox. You need it. But once again, you need an integrated approach. You need a number of methods. Herbicides in isolation might give you control, but if you want a real solution, you need to have a toolkit. So look at biological control. We'll target certain stages of the growth forms. They will target certain life cycles of plants. So biological control, part of the toolbox. Have a look at your grazing patterns. After bush is treated, great if you can let it rest. I know it's difficult with livestock, but normally resting is great. Build up a seed bed, but it goes hand in hand with your grazing management, because once those trees are gone, you're going to get bright new grass popping up, and the grazing pressure is normally intense. Clear different sections, not all in one area, that type of stuff. Fire, it's a very hot topic, but it can be used. Once it's dried out, a soft, quick hot fire, uncontrolled, germinates a lot of the seed, and it's easier to follow up. So it is a great tool. What we do while it's Terravusa and our sister company Terraligna is that wood that you guys are sitting on has great economic value. Some of our long-term projects, we make restaurant-grade charcoal, biochar. The wood has been tested, no residue of any active within the wood. It's up to European units standards. We create a whole value chain for you guys. We don't see bush encroachment as a headache anymore. We see the economic value of bush encroachment. And this is where the community comes in now. It's not hard work uprooting, kicking a beast, that a war that you're not going to win. There's a whole supply chain now. There's economic value. So Terravusa can help with that, and our sister company, Terraligna. But before you get going, and if I were you guys and you're looking at chemical control, there's a few questions I'll ask myself. What is the degree of selectivity? And you guys need selective herbicides. Is there any residual action? We can prove that all these herbicides, or the new premier herbicides have been registered in the US, the European Union. So there's a lot of information available on this. And then what is the danger to humans? We often overlook, we talk animals, but the human applying it, our livestock. Underground water, we need to take that into account. And what will it do to our non-target species? We mustn't always look at cost. We need to balance economical decisions with ecological decisions and try to get a base here. And maybe we're wrong in South Africa. We're quick to go to the economical aspect of it. To give you a quick rough indication, it will cost you $94 to clear it for your chemicals, Dicrostachys by air. Not your application cost, just your chemicals. So the cost is not the chemicals, it's your labor. Guys, there's so much I would like to say. Let's continue the conversation. Thank you for having me. It's a topic close to our hearts. All we do is bush encroachment, alien plants. We pride ourselves on our solutions. Keep in contact. Any further questions, any information you require?
There's already a very interesting question from Courtney, a very practical question in the chat. To avoid non-target trees, is the drone going based on the non-target species 3 heights, or are there other identifiers that the drone system is going on? And secondly, have you found there is a lot of kill in non-target species that are close to your target species? You mentioned chemical selectivity to help in avoiding non-targets, or is this something that just has to be accepted to control your target? Okay, there's a lot to unpack.
Thanks, Johan, Courtney. Maybe a bit of both. Each area is unique. Let's look at the premium products. It will control anything within the family Fabaceae. So it can't tell the difference between a Acacia nilotica and a Dicrostachys. So all those trees are within the spectrum of control. If it's broadleaf trees, a lot of time the guys spray straight over those trees, no problem. The drone is a game changer. Because if you look at bush encroachment, it's normally an event. So if you walk into a bush encroached area, they're all of the same height. They're almost all of the same type of age. So that's great for us because then we can immediately exclude the target trees, not even spray over them, and the drone will work around it, yes. Or if it's knapsack type of based work, in the past we used to keep buffer zones and not go close to non-target trees. Nowadays we spray right underneath the canopy, yes. I think it's specific to each area and what type of trees you have in there. If that covers it shortly.
I think a question on many people's minds while we were preparing for these conversations were, what are the health and safety risks in terms of the people applying the chemical?
No, it's a good question. Limited. I think as anything in life, there are your ammonia in your grocery cupboard comes with certain instructions. Always follow the label instructions. A lot of accidents tend to happen while mixing, while transporting of chemicals. So it's very important to have a policy on the transportation and warehousing of chemicals. At the end of the day, it comes to respect. You got to respect it. But they are slightly hazardous. You need long-term type of exposure. A bit of training in the field is to continually drift. If you see that the drift is going in a certain direction, teams need to change. And so, yes, awareness. But if you look in the day, we used to treat cacti with MSMA. Now, MSMA is a red label. It's arsenic-based. That's horrible stuff, man. That's been totally phased out. We use natural plant oils now to treat cacti. So follow the instructions, basic PPE, yes, but compatible. The label. Okay. And if you look at the LD50, you need a worker. A lot of the incidents also were man-induced type of stuff for these chemicals. And now if you look at it, a man needs to consume almost 50 liters of that active. Yeah. So yeah, that's what drives us, man and animal.
Malcolm, yeah, is there in adjuvants that you can add, like a way to make the wind drift less? And then there's obviously also environmental conditions, certain environment where you can limit your effects on non-targets if you spray under the right wind condition, wind speed, wind direction, all of that. So I think there's other tools that we can use that can help the herbicide be more effective and minimize the effect on non-target species. I don't know if you agree or disagree.
No, absolutely. It's if you just look at droplet size, make the droplets a little bit bigger so they don't drift away. There's a foaming agent that we can use, creates a herbicide almost like a foam, and then that sits on the leaf. Very much so. We've got great tools now.
Hello, everyone. Just want to first say, Malcolm, that was a really, really nice presentation. Picked up quite a few things there. My comment surrounding the drones, I've seen the application being done once on a relatively small block targeting Chromalina. And obviously, there's a bit of concern, and I think Gustav actually helped to answer my concerns in the fact that you can actually alter the drone itself. If you want to do different droplet sizes, if you also want to make that effect of when the drone is actually flying over a certain area a bit less, because it does tend to push open the area just beneath it, just with the force of the propeller and where it's flying. So more of a comment, not really a question there. I think everyone really did well to answer what I wanted to know. On that, just to further that topic, have you tried to look at trying to increase selectivity based on the plant species with drone technology in terms of like using spectral signatures of plants? I know there's quite a in-depth thing to actually take on, but I'm not sure if anyone has actually tried to start doing that within South Africa or across the globe.
No, very much so. It is great to adjust your height. You fly low, you can fly right above the canopy, that type of thing. The drones are a great tool. They're not your silver bullet. It all goes about the operator. In order to operate a drone in South Africa, you need a pest control license. You need to be registered. So that's where a good quality operator, pilot, comes into play, where you will get to a land and then say, okay, this area is thick, we need to up it to 80, or it's too hot now, let's come back at later sunset type of thing. I don't want guys to think that drones are going to replace the community or the labor. Drones are just going to assist. And then, like I said, the community work can still come in. To expect communities to spray millions of hectares in South Africa, your success rate is also low. Hard work, you get tired. So immediately your success rate is low. It's difficult. We don't always promise 100%, but you got more precision application. And then we can measure and monitor, keep record keeping. Guys don't keep records. There's no record keeping. So in terms of continuity and going forward for a long-term plan, that's where I like the drones. That record has been kept. We know where we stop. We know where we start next year and so forth. That is a game changer.
Right. Thanks, Courtney. Very good questions. There's a question from Anelia, and this is maybe drawing a contrast to the chemicals that Malcolm is talking about here. Has anybody looked at the effect of herbicides on the soil life? And this is a very important one. I know it's on the mind of the people in Uganda as well. I did some work on Roundup, and it changed the soil community totally. So Roundup is maybe the big bad wolf of the industry, as it's feared in that sense. So Malcolm?
Look, there's always need for more research, African-based research. Conditions are different here in Africa compared to where all the studies have taken place. I'm busy with my masters at Swallow Kalahari Reserve. So there we've tested soil for persistence. So there's some great results we can share with your team. In terms of the newer herbicides, yes, they're all registered in the EU, the EPA in the States, and even our registrar, the toxicology reports. If you want to try bring a new herbicide to the market that's non-selective, persistent in the environment, you're not going to get it registered, type of thing. But yes, so there's a whole lot of information we can use. Unfortunately, a bulk of those studies are going to come from North America.
Okay. Thank you,
sorry,
Malcolm.
You'd also just have to weigh up the risk versus reward type of thing, you know. Well, what would be the risk of those plants staying there and their consequences versus a very little to none alter in your soil type of thing. But we always like to say very little to none for the new chemistry. And then we can share that screen that I'll send. The mobility or the activeness in soil is 0.6 days. So you in and out, it's not persistent. The brothers before it are about 90 days, 120 days persistent. Yes, then the change is big, I think.
Malcolm, a last question from Dorothy. I want to work it in because I know it's on the minds of the Ugandan experts there as well. Has research been done on recovery, especially in grasslands where herbicides have been used? How long after did the grasses start growing back?
No, and it's a wonderful question. Look, South Africa is very diverse. We've got Kalaharis that are very arid savannas to the more low-fight Kruger Parks of the world. On average, it's within a couple of weeks. I'd say on average, 2 to 3 weeks, you could see the grasslet comes through the target plant sometimes, type of thing. Some areas where you get less than 300 mils of rain a year, it's probably a bit longer. But that's the immediate sign that the herbicide is in the plant and working, is that massive uptake on grass. No, it's instant and when I say instant, within a month or so. But that is the correct tool for the job. That one photo I showed you of a non-selective application, that would take about 2 to 3 years for that grass to come back. And now in that period, you've got bare open land, which is prone to another plant invading that area. And then 2 to 3 years, you sit with a different problem, different plant. Once you get a good grass basal cover, it's very difficult for another plant to come and try establish itself in between it. And that's why we recommend start clearing where they're spreading. So prevent further spread, kill that target tree, the grass immediately. And then we treat the thick stuff last. Your return on your investment on the thick stuff takes longer. The grass takes longer to respond. And you normally get a massive... Dicrostachys seed can last for very long in the soil, many years. It's a long-lived type of seed. So once you go into the thick stuff and you declare war, you must know you're going to follow up there. But to get quick return is prevent further spread on your grass.